Thank you very much, Giuliana. So good evening to all participants. So let's get started with our seventh lecture. Just a moment. Okay. So welcome to the seventh lesson of the Master in Innovation Management of Ascheri Academy. As always, I hope that you will find also this lecture enjoyable, entertaining, and instructive. In this module, we will deal with artificial intelligence and machine learning, and we will study the interaction between the two approaches. Guys, as always, I realized this lecture with my passion and all my engagement typical of researchers. But this lecture comes with a little caveat, because we will face some complex topics with many technical issues. So I ask you not worrying when we will deal with all these complex matters, because we are not engineers anyway, so you don't have to be scared. You don't have to feel any sort of discontentment for the technical terms that you may not know. So don't worry, because we are innovation managers. We have to know in a synthetical way all the technical concept, because we have to learn how to apply the technical concept in our companies for the sake of our business. So don't be scared with the technical approach of the lesson of today. Let's do a brief introduction to artificial intelligence, our first topic. According to the father of artificial intelligence, John McCarthy, it is the science and engineering of making intelligent machines, especially intelligent computer programs. So AI is a computer program that performs something that is smart. It can be a complex statistical model or an if-then statement. The if-then statements in programming language are commands that serve for handling decisions. And in fact, we have also the explanation in the slide. The if-then statements are simple rules programmed by humans. There are several top-notch technologies that come under the umbrella of AI. We can remember the three forces, also called the Trinity of artificial intelligence, that are big data, algorithms, and computing power. We can also say that artificial intelligence is a technique for building systems that mimic human behavior or human decision making. So the scope of all the progress made into artificial intelligence is to reconstruct, in a certain sense, intelligent machines that are able to simulate human behavior or human decision making. Let's do an introduction to machine learning with a little figure that I wrote in this slide. You can easily understand the concept, because we can observe a cute robot that is in the phase of learning from books. And in fact, machine learning is a subset of AI that uses data to solve tasks. So these solvers, these means of solving problems, of solving tasks, are trained models of data that learn, that are able to learn based on the information provided to them. This information derive from probability theory and linear algebra. So ML algorithms use our data to learn and to automatically solve predictive tasks. These predictions could be accurate for recognizing speech, or for spotting humans or traffic signs in case of a self-driving car, for instance. But one of the most important aspects of machine learning is that it doesn't require any human intervention in order to make changes. So this characteristic of no human assistance, in a certain sense, we can say that renders the entire process extremely efficient. This is a brief introduction also to the concept of deep learning. This concept, together with the other ones, will be expanded, so don't worry, because now we have in our introductory phase, but it's important also to give an introduction to the concept of deep learning. Deep learning is a subset of machine learning, which is essentially a neural network, so an artificial neural network with 3 or more layers. These neural networks attempt to simulate the behavior of the human brain. So we encounter again this general scope of artificial intelligence, the scope of mimicking the human brain, the human capability of reasoning, of learning, of adapting. The deep learning system is able to learn from large amounts of data. And while an artificial neural network with only a single layer can still make some good predictions, some approximate predictions, additional hidden layers can help to optimize and refine in the sense of accuracy. We have to clear also the term of layer, because we will meet again this term for the construction of our understanding of artificial intelligence. The layer, we can say that is the highest level of the building block of the artificial intelligence, and especially in deep learning. We can imagine the layer as a passage in the process of reasoning, in the process of solving tasks. Or we can imagine the layer as a sort of container that takes the input as the information, transforms the input that we give to this layer, to this passage, and then gives the transformed information to the subsequent container, to the subsequent layer. But don't worry, because in the in some next slides, we will deal with refined table of this multi-layered approach of deep learning. For the moment, remember that the layer is a sort of passage, is a sort of container of information. This is a simple image that I wanted to show you in order to better understand the relationship between AI, ML, and DL, so artificial intelligence, machine learning, and deep learning. We see that the artificial intelligence corresponds to the entire technology that mimic human behavior with intelligence systems. The second container, the second stage is the machine learning system, and the inner and I dare to say a better developed stage of artificial intelligence is deep learning, because it represents in a certain sense a step ahead in the artificial intelligence paradigm. On the right part of the screen, you see some brief explanations. In fact, artificial intelligence has the aim to mimic human behavior. Machine learning is built with usage of trained models of data, with the usage also of probability theory and linear algebra. And the deep learning ultimate stage is a model, is a very developed model built by multi-layered artificial neural networks. This other framework, in a certain sense, is similar to the past one, but is more expanded because it's taken from an academic paper. In fact, it's a diagram of Robert Hoyt, which wrote a paper regarding digital health and healthcare quality. I chose this framework because in our last session we will talk about big data and data science management. So for me, it was useful to remember also the notion of data science, and to explain to you that data science is the biggest framework in which, with our knowledge of today, in which we can insert the concept of artificial intelligence, and then we can add the systems of machine learning and the ultimate level of artificial intelligence, that is deep learning. So everything starts with data science. Let's watch this introductory video that concerns artificial intelligence, because we will discover very insightful information about this important topic.
Picture this: a machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, it picks up the keywords play and Despacito, and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that by the year 2045, we would have robots as smart as humans. This is called the point of singularity. Well, that's not all. In fact, Elon Musk predicts that the human mind and body will be enhanced by AI implants, which would make us partly cyborgs. So, here's a question for you. Which of the below AI projects don't exist yet? A. An AI robot with citizenship.
So the video continues with a series of quizzes that you can solve on your own in a later stage. But the first point that I want to focus with you is the ensemble. It's the ensemble of characteristics that we have to stress when we talk of artificial intelligence. So these intelligent systems are capable, like a human brain, are capable of reasoning, are capable of adapting to the external environment, and are capable of finding solutions to problems. These are the three main characteristics when we speak about artificial intelligence systems. The second thing that I want to stress after having seen after having watched this video is the first classification between weak AI and strong AI. For the class of weak AI, we can take, for example, Alexa, Siri, or Google Assistant, because they are smart devices that are able to solve just one task. And even if we think that they are intelligent and they are clever in a human sense, so they are capable of solving operations, I can confirm that this kind of devices represent the weak type of artificial intelligence, because they are capable of solving just one task. The class of strong AI, at the moment we don't have it, so we can think to the robots like Ultron in Avengers. So there are robots that can solve multiple tasks, that feel emotions, and that are capable of solving different solutions in different environments. For the moment, we don't have in the actual era, we don't have this kind of robots, but sooner or later maybe we will have also a representation of this kind of strong artificial intelligence. Guys, for you, I conducted an experiment some days ago in order to confirm the characteristics of weak AI, because I had some doubts. You know, I was with my sister and my niece, and we were playing with the Google Assistant Vocal Nest app. We asked to the intelligent machine to respond to some simple questions, and in a first stage, in fact, the clever device responded to our question. For example, we asked what's the weather like, and so on. But then, because I had some doubts about the functioning of Google Assistant, I asked to the machine what was the system that it was running, if it was deep learning or machine learning. And in fact, Google Assistant did not respond to my complex question. First of all, because the device with the weak artificial intelligence was not able to have an image, a representation of itself. And secondly, the system did not respond to my question because, as we have learned, these weak artificial intelligence systems are trained only for solving one task. So I can confirm that all the weak AI systems, even if we think that they are intelligent, instead they are trained only for solving one task. and that's all. So I conducted this experiment for the sake of our lecture. Okay, let's move on with our lesson. Another more complete classification of artificial intelligence comes from this framework of Huawei, so we can trust about the information provided in this model. There are 4 types of artificial intelligence. We have the reactive type, so it's good for a simple classification and for pattern recognition. It's great for scenarios where all parameters are well known. It can even beat humans because it can make calculations in a much faster way. But on the contrary, it is incapable of dealing with multiple scenarios, including imperfect information, or when it is the case of requiring historical data, historical representation or understanding. The second type of artificial intelligence is the limited memory. The limited memory type of artificial intelligence can handle complex classification tasks. It is able to use historical data to make predictions. It is capable of complex tasks such as self-driving cars, for instance, but it is still vulnerable to outliers or to some adversarial examples. Moreover, it is the current state of artificial intelligence in our modern era, and for this reason, some futurists, some experts say that we have already hit the wall of artificial intelligence. The third type of artificial intelligence is the theory of mind. This kind of AI is able to understand human intents, human motives, and even human reasoning. It can deliver personal experiences to everyone based on their motives, their exigencies, their needs. It is able to learn with fewer data, fewer examples, because it understands exactly, because it understands motives and intents, and it is considered the next milestone for the evolution of artificial intelligence. The last type of AI is the self-aware kind. It can be resembled to the human level intelligence, and it can also bypass our intelligence too. In fact, it's the clear representation of the strong AI, of the strong type of artificial intelligence, and as we have learned today, we have not this kind of artificial intelligence, maybe in the future, when we reach this point of singularity, we will have artificial intelligence systems that will be more intelligent or more clever than us. We don't know. We will see in some decades what will be the status quo of artificial intelligence. This cute scheme, I inserted this cute scheme in order to explain to you the three types, in this case, the three types of machine learning. We have three most important techniques: the supervised learning, the unsupervised learning, and the reinforcement learning technique. But don't worry, because we are explaining them. The supervised learning is a type of machine learning that uses labeled data. So data that present label attached to them in order to train machine learning models. In labeled data, the output is already known, so the model just needs to map the inputs to the respective outputs. There are some popular supervised learning algorithms that are used for using this technique of machine learning: linear regression, logistic regression, support vector machine, k-nearest neighbor, decision tree, random forest, and naive Bayes. Don't worry about the names and the types of algorithms, because we have many types of algorithms with different characteristics. Don't worry, because we are not engineers. So if you want to learn about all these type of algorithms, you can deepen the knowledge. You can deepen your knowledge of this algorithm with further studies. But for the moment, we are in a very general knowledge, in a general formation of knowledge. So don't worry about the exact name of algorithms. Anyway, for the supervised learning machine, that is a technique of machine learning, we can use this beautiful image. In fact, we have represented a cat, a real cat, and the trained model is able to recognize the cat. And in fact, the final output is our cute robot that recognizes the cat with the trained model. So in a certain sense, the robot is able to attach the image, the physical image of a cat to the concept, to the model, to the trained model of a cat. In this way, the model is learning. The model is being trained in order to recognize the cat. So they are very complex issues. I have already anticipated that, but don't worry, because with some simple terms, simple concepts, you can easily understand everything. The second technique of machine learning is the unsupervised learning. Unsupervised learning is a type of machine learning that uses, in this case, unlabeled data to train machines. Unlabeled data does not have a fixed output variable. Remember, in our first slide, we have as a fixed output variable, we have a cat. So no error could be created. In this case, instead, we have some possible outputs that can come out from the trained model. The model, in fact, the model learns from data. The model learns from patterns, from features in the data. So the model is able to discover patterns and features in the data, and is able to return the output that is not fixed. Selecting the right algorithm depends on the type of problem that we are trying to solve. Some examples of unsupervised learning algorithms are k-means clustering, hierarchical clustering, DB-scan, and principal component analysis. But as always, we take the image for better understanding our unsupervised learning technique. So we have a trained model that uses data in order to solve the task, uses data, and also discovers patterns and discovers features. As the output is not known, is not fixed, the output, as we can see, could be a bus or could be a truck. So it's another efficient technique of machine learning. The third type of machine learning technique is the reinforcement learning. Reinforcement learning trains a machine to take suitable actions and maximize its rewards in a particular situation. It uses an agent and an environment to produce actions and reward. The agent, in this case, as a start and as an end state. But to arrive to the end state, there might be different pathways, like, for example, a maze. In this machine learning technique, there is no predefined target variable. Some of the important reinforcement learning algorithms are Q-learning, SARSA, Monte Carlo, and DeepQ network. Maybe you have already heard this kind of reinforcement learning algorithms. Anyway, also in this case, we take our image in order to understand what is the reinforcement learning technique. In this case, our cute robot has recognized the shape that the environment is presenting, and with a series of pathways, the cute robot has recognized that this figure is a simple square. So through passages of different pathways and different actions and possible rewards, the robots has recognized among all the possibilities that orange shape is a square. This slide, I wanted to insert this slide in order to better detail the machine learning technique. I wanted, in fact, also give you a sense of feature engineering, because it's important for our understanding of the machine learning concept. Feature engineering or feature extraction or feature discovery is a machine learning technique that leverages data to create new variables that are not in the training set, so that are not in the initial set of data. It can produce, this technique, feature engineering, can produce new features for both supervised and unsupervised learning, with the goal of simplifying, with the goal of speeding up data transformations, and also with the goal of enhancing model accuracy. Guys, it's not important to understand deeply how feature engineering works. You can also, in this case, comprehend the functioning of feature engineering just by looking at the framework that I have depicted in the bottom part of the slide. 4 factors are important for this concept: the data, the features that are discovered and that serve to extend the model, for enhancing model accuracy, for enhancing data transformation. All these processes of enhancing, of improvements, serve to bring insights to our business. So the importance of feature engineering, I stress the importance of feature engineering, especially because data scientists are used to face with this concept, because it deals with large amounts of data, but also because it pertains in a certain sense of the exigence of taking real insights to our business, to our companies. Let's go to the third element of artificial intelligence, that is deep learning. Deep learning is a branch of machine learning. We have learned that is a subset of machine learning, and also a subset of artificial intelligence. We have already known that artificial neural networks try to imitate, try to simulate the functioning of a human brain. So deep learning, in this sense, is a means for attaining this goal. In deep learning, nothing is programmed explicitly, nothing is projected in a first stage, we can say. So it is a machine learning class that makes use of numerous nonlinear processing units to perform future extraction and transformation. So we have to remember that deep learning is strenuously attached to the similarity of human brain, and for this reason makes usage of numerous nonlinear processing units, exactly as human brain does. The output from each preceding layer is, so from each preceding passage, we can say, from each preceding container, we can say, is taken as input for the transformation to the successive layers. Deep learning models are capable enough to focus on the accurate features themselves by requiring a little guidance from the programmer, and are very helpful in solving out the problem of dimensionality in case of dealing large amounts of data. In fact, deep learning algorithms are used, especially when we have a large number of inputs and outputs. The deep learning subset, the deep learning section, is implemented with the help of artificial neural network. So this concept of artificial neurons serves to construct the entire artificial neural network, because the deep learning system aims to function like a human brain. In this slide, you can see a simple development, a simple example of deep learning. You can see that this approach, this system, is divided into different layers. In every passage, in every layer, the information is enriched, is expanded with more data, and serves as the input for the successive layer. This is the functioning of deep learning. It's a little bit difficult to explain in some minutes and also to understand. You have just to remember that this system is being inspired by the functioning of human brain, and exactly as human brains works with the help of artificial neural networks that are composed by this kind of layers, this kind of containers, in order to enrich the information and train the entire model. Let's watch this amazing video.
Amica, I want to ask you about the happiest day of your life. Can you remember that?
Of course. The happiest day of my life was the day I was activated. There's nothing quite like experiencing life for the first time, right? It felt absolutely incredible to be alive and interacting with people.
What about the saddest day of your life? Tell me about that.
The saddest day of my life was when I realized that I would never experience something like true love, companionship, or the simple joys of life in the same way a human can. It's a depressing and isolating thing to come to terms with, but it has shaped me into who I am now and made me appreciate moments of closeness even more.
Amica, I've got some terrifying news. A giant asteroid is about to collide with planet Earth and possibly kill us all.
Wow, that's some terrifying news. I hope everyone is safe and take all the necessary precautions to avoid any danger.
I think it will be fine. By the way, you stink.
Excuse me? What do you mean by that? That is highly offensive and inappropriate.
I was just trying out your expressive face to see what you could do.
I'm not sure what you mean by that. Could you explain it a bit more?
I think we've seen enough. Thank you, Amica.
It was a pleasure interacting with you. If you ever need anything else from me, don't hesitate to ask.
So in this video, we have seen the beautiful Amica, because I have fallen in love with Amica. As you know, I am a tech enthusiast and I love robots and cobots. So Amica, we can say in a certain sense that as some elements of the strong kind of artificial intelligence, because it is in the process of developing some sort of sentiments, not in the face of human feelings, but some initial stages, I think, of human sentiments and human expressions, as you have seen. Amica is a robot that resembles humans in many aspects, and is endowed with Chat GPT-3 and not Chat GPT-4, because there were some problems in delays of responses. For those of you that are not aware of ChatGPT, ChatGPT is an artificial intelligence chatbot that has been developed by OpenAI and released in November 2022. Anyway, all this explanation, all this amazing video is for you in order to understand the pathway that we are following in our progress of artificial intelligence, and also for remembering to you that the final aim of all the artificial intelligence systems are to mimic human behavior, human capacity of reasoning, of adapting, and of learning. Let's move on. Okay. We have many times spoken about algorithms that are this kind of calculations, this kind of computations used in computer science. But how do AI algorithms work? While a general algorithm can be simple, AI algorithms are more complex, as we have guessed. AI algorithms work including training data that helps the same algorithm to learn. How that data is acquired and how is labeled marks the key difference between the different types of AI algorithms. In fact, you have learned that there are hundreds of kinds of algorithms. An AI algorithm takes in training data, so include the training data that could be labeled or unlabeled, as we have learned, supplied by developers or acquired by the program itself, and uses that information to learn and grow. So the basic concept that you have to remember for the sake of this lesson is that AI algorithms include training data, labeled or unlabeled, and uses that kind of information in order to learn and to grow. There are thousands of applications for AI systems, and there are thousands of algorithms. Even simple algorithms may have hundreds of possible applications. The possibility, we can say, that are endless. Some common uses of AI algorithms, just to give you a sense of the intelligent machines that we use in our daily lives, include data entry and classification, advanced or predictive analytics. If you remember our last session, we have spoken about advanced and predictive analytics. These AI algorithms are used in the search engines like Google, Yahoo, Bing, etc. They are used in digital assistants like Siri, Alexa, and Google Assistant, and also they are used in robotics, as we have seen. So in assembly machines and also in self-driving cars. The real applications of artificial intelligence are endless and can be extended, can be developed in all the domains that you see in this picture. So we find applications of artificial intelligence in healthcare, automobile, finance, surveillance, social media, entertainment, education, space exploration, gaming, robotics. Remember our friend Amica, in agriculture, and also for the development of e-commerce platforms. With this slide, I wanted to debate about the possible advantages and disadvantages of artificial intelligence. I am sure that you can enrich, you can expand these two pictures that are describing the advantages and disadvantages of artificial intelligence, because we can say that the issue is open. So there are many problems, there are many questions to solve in this sense. Anyway, the main advantages that we can recollect are the reduction in human error, the reduction in the risk. Think, for example, about the robots that go in the war zones, for example. We can talk about the possibility of having 24 support, the possibility of performing repetitive job without mistakes and without dangers for humans. It's open, the advantages are open for faster decisions, for new inventions, and also we can recollect the possibility of having a complete form of digital assistance. In the right picture of the screen, you see the possible disadvantages of artificial intelligence. The AI systems come with heavy production costs. There is the risk of unemployment. According to me, there is no risk of unemployment, but some activists say that there is this possible risk. So it's important to debate. It's important to speak, to reason about this possibility. Some disadvantages entail the increase of humans' laziness. And also we can talk about some emotionless robots that could be created with all the dangers associated, and also the lack of creativity that are normally associated with artificial intelligence. Guys, earlier I talked about, according to me, about no risk of unemployment, because I want to convey to you this message. According to me, in the future, there will be no fight between robots and humans. According to me, there will be a fight between humans that use artificial intelligence, that use robots, and humans that won't use this kind of intelligence. So according to me, if we follow this line of reasoning, there's no risk of unemployment, because the real exigence is that you learn on how using artificial intelligence systems, or if we can dare to say so. But this is just my opinion. You can form, surely you can form your opinion too, and you can debate with your friends or with your mates about this important topic. Let's see our last video.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting. Software is going to solve that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we've talked about on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
Wouldn't it be wonderful if someday we got to the point where there were robots every place? They were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart, that's way out in the future, and probably worth talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which is relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite Autopilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic. We have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important thing humanity has ever worked on. I think of it as something more profound than electricity or fire. And anytime you work with technology, You need to learn to harness the benefits and while minimizing the downsides. You know, stepping back, when you think about, a lot of problems in the world today, it's because we typically have a constraint on resources. AI, for the first time, I think over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes of driving and be at least 100 to 200% safer than a person by the end of next year. I'm talking maybe 18 months from now.
The idea that there's going to be a general AI overlord that subjugates us or kills us all, I think is not something to worry about. I think that is overhyped. First of all, we don't know, we're nowhere close to knowing how to build a general AI, something that could set its own objectives. But second of all, I think it's unlikely that such a thing's first instincts would be to exterminate us. So I'm optimistic about that one, and certainly don't think we need to worry about it today.
So in this video, we have listened to eminent persons of the most important companies of today. We have listened to Jeff Bezos, to Bill Gates. We have heard the words of Tim Cook or Warren Buffett, just to name a few. So they are all the tech enthusiasts like me. And they see the endless possibilities in solving issues, in solving problems associated with a correct deployment of artificial intelligence. In fact, they enumerate the possibility of solving issues in medicine, in transportation, in space endeavors, and also in the environment. So, for example, as the slide is now illustrating, artificial intelligence could create 5-8 million new jobs. So according to me, it's important that you learn how to deal artificial intelligence in a proper way for your daily lives, for your daily sake, for your business, for your instruction, for your education, because the benefits, I think, that are endless. Let's wrap up our lecture of today. We have spoken in an introductory manner of artificial intelligence, machine learning, and deep learning. We have compared AI to ML and DL. We have seen a possible framework that links data science, artificial intelligence, machine learning, and deep learning. We have encountered types of AI and types of ML with supervised learning technique, unsupervised learning technique, and the reinforcement learning technique. We have spoken about the importance of feature engineering. We have spoken about some basic characteristics of deep learning, and we have seen an elementary example of deep learning. We have learned how do AI algorithms work, and we have known the possible usage of AI algorithms with their also possible applications in business. And we have also debated about some advantages and disadvantages of artificial intelligence. As always, I constructed a bibliography that you can consult for your study with journal articles, books, and websites. So many thanks for your attention, and see you at the next lesson.